Hi, everybody. Today, we're going to be chatting about Databricks Delta Live tables. So my name's Niall. I'm an independent consultant working on kind of Azure data platform, primarily Databricks. Came originally from kind of like a background of on-prem, so I've done a lot of the kind of things in the background that everybody did on-prem, and then moved that up into the cloud and do lots of Spark. I do a bit of blogging, and you can feel free to contact me on LinkedIn. If you want to grab a photo so that you get the GitHub link, there will be code up on there that goes with all the demos of this in a few days. So basically, today, what we're going to cover, we're going to have a look at what Databricks Delta Live tables are. We're going to try and work out what problem they are trying to solve with this, what technologies are they built on, so how do we use them, and what are the things that can actually catch you out when you try and use these things. So, start at the beginning. What are Delta Live tables? So, Delta Live tables is designed to be a declarative ETL framework. So what do we mean by an ETL framework? What does that need to be able to do? Well, for starters, it's Delta Live tables, so it's going to store the information in the Delta Lake format. And the idea here is that it's declarative. So we're going to build our ETL pipelines using notebooks, and it's essentially then going to be able to work out what the interdependencies are between our tables. So it also supports some things that are really useful for that. So it supports incremental loading. It's got built-in data quality metrics. It has a monitoring dashboard, so we can see actually what's going on. And it makes rerunning things when stuff fails or when you need to rerun certain tables really fairly easy. So a quick one for anyone who's not familiar with Delta Lake. How many people here use Delta? Hands up. OK, most of you. So Delta Lake is basically Parquet files with a transaction log. That's pretty much what it is. The transaction log itself is predominantly a Parquet file, and then you will have the most recent entries are actually just stored as JSON, so that it's quick to read and write it. And Parquet files, they're columnar, they're compressed, and it's an open source format. So even if you're using Delta, you can still look into those files that you've got, and you're not tied to Delta, essentially. It supports time travel. So this, because it's got the transaction log, it gives us the ability to say, I want to see my data as it was at a certain point in time. It allows for upserts to update our data, and we can actually delete data as well. We can look at historical records, and we can actually remove those historical records so that we can have better performance. We've got less data there for it to look through, and for GDPR compliance. And also, compared to Parquet, when we're working with Spark or Databricks, there's a whole bunch of performance optimizations. Because of that transaction log, it can store things like extra information about how many records are in files, and it can store it in a header of, instead of being in the header of the Parquet file, it's actually just in the transaction log, and it can get to it quicker. So, OK, what problem are we trying to solve by using Delta Live tables? So one of the problems that we've had for a long time is trying to do incremental loading of things. So essentially, we've got data, and every day we want to pull in a certain amount of data from a source system. And if that source system's big, we do not want to pull all of the data every single day and reload it, because that would just take a really long time, and it's just expensive. So the idea is we want to be able to say, give me what's changed, and then have the framework track what files have come in, what files we've loaded, and work out how to load those things so that we load each file exactly once. We don't want to have duplicates. We want this to be nice and fast, and we want it to be a reusable pattern. So there's a number of ways we would have done that in the past. We might have looked into the storage folders to say, what are all our files, and kept track of the files that we've already loaded, compare the two. That tells us what's new. The problem that you get with that in a data lake is that listing files is not a very performant operation. If you've got hundreds of thousands of files in a folder, getting the list of the things that's there takes a really long time compared to on a sort of more traditional file system. So how might we get around that? Well, you might go, well, we could essentially keep a list of the new things coming in using a trigger on that storage, and then we could compare that to what we've already loaded. And essentially, what the incremental loading is doing in the background with Delta Lake is it's built on a technology we'll look at in a second called autoloader, and it handles all of that behind the scenes for you. So it means that we haven't got to kind of go with these DIY options of storing what we loaded last or working out what is the difference between things. We don't need to worry if our source system sends us files that don't have a date format on them and they're just a random file name. It doesn't matter. It'll sort it out for us. So what technologies are being used under the hood to make this work? So autoloader. So who here has used autoloader with Databricks? Yeah, a few of you, quite a few of you from Advancing Analytics. Basically, autoloader is the framework that is doing this underneath. So essentially the way it works is when your files get dropped into your lake, there is a trigger that is basically listing the things that are new, and then it pushes that into a database, essentially, to give us a list of all the files that are currently in our storage. It also then reads that, and as it writes it, it updates the files list to say these things have been read. So essentially, it's making sure that we don't have to keep listing all of those files out, but it keeps track of what's loaded and makes sure it happens just once. And then the other tool the other technology that this is built on top of, and it's really important to kind of understand a little bit about, is Spark Structured Streaming. So Spark Structured Streaming is designed to be a fault-tolerant stream processing engine. So what does that actually mean? Essentially, it allows you to write streaming jobs that look like batches. So you write a job that looks like your normal batch processing that you've done before. And under the hood, it's basically doing micro batches. It takes small pieces of data and it processes them as if they were a batch, which makes it far easier to deal with. And it can do that over and over and over. So when we run it, we can say, run this thing and just leave it to run. Or we can say, and just keep going, and when new data comes through, it just picks it up. Or we can say, run once, and it will pick up from where it left off, run as much data as there, and then it will stop. And it takes care, again, it's like autoloader, it takes care of making sure that you load your data exactly once. And it tracks its state using a bunch of checkpointing and log files. So they basically sit in your data lake next to your data, and they're what is used to track that state. The thing is, if we keep going and we say, just run, and every time new data comes in, process it, if your data doesn't turn up very often, you essentially are going to keep your cluster alive, and it's going to sit there running just so that it can keep going and say, OK, when new stuff comes in. So depending on how often you actually need to update things, you would probably want to maybe not leave it on in streaming mode a lot of the time. A lot of customers, you'll find they'll say, yeah, we want real-time information. And you look at how often do they actually look at that report, and it's 3 times a day. So have a think about what the actual requirement is, and maybe actually just call it with trigger once, like multiple times per day, in order to process that in. In terms of how quickly the kind of response is on streaming, it's generally around 100 milliseconds for a micro batch. So you can have another one trigger at that kind of cadence. So if you've got lots of data coming in on an IoT stream, it can handle it. OK, so Delta Live Tables are built on those 2 things. So how do we actually build Delta Live Tables? So we build them with pipelines, and these are based on notebooks. So we use a notebook, and we define a query that is used to load our tables. However, notebooks for DLT are special notebooks. You cannot run them on a normal cluster. So that can be a little bit tricky. And essentially, within our notebook, we can define a table. So we say, create live table, and then we define the query that puts the data into there. If we want to pull data from a stream, then we say, create a streaming live table. And once we do that, that means that we will be able to pull data from that streaming table incrementally. It will keep track of state, and things that access it will be able to pull from where they last left off. And you'll notice that within here, we've got from and live before the table name. Essentially, that's within our pipeline. It's able to work out what the dependencies are between these by using that live keyword. And then we also can create views within our notebooks. So views within a DLT notebook are a kind of slightly strange thing. You create a view in Spark SQL, and you can see it in the meta store, and you can look at it as if it's a view on your tables. When you create a view in a DLT notebook, the only place it exists is within that DLT notebook at the point of execution. So essentially, they're like a fancy CTE, except you can refer to them with multiple different queries, and they get persisted throughout the thing. They're in a materialized view. So you can use that to improve the performance if you've got large queries by breaking it into pieces and using the views there. OK, so how do we run these pipelines once we created our notebook? Well, basically, from the Workflows tab, we can create a pipeline. And when we do that, we get a bunch of options to choose what we actually want to run. So the most important decision we have to make up front is what addition do we want to actually run for our Delta Live pipelines. So we've got core. Core is basically basic integration. It does stuff like autoloader, it does the streaming part, and it allows you to make a basic integration pipeline. Then we've got pro, and they call it CDC that they've added in here. Basically, CDC on lots of other source systems means kind of change data capture, give me the things that have changed. Within Delta Live tables, it basically means that you can do upserts and merges within your Delta Live tables. And then we've got advanced. And that adds the CDC feature, but it also adds data profiling into that. So when we want to actually edit our pipeline and add notebooks into it, they've gone with a slightly strange terminology here. Normally, when you run a notebook, and when you have a cluster, you can add libraries to it. And those libraries would be Python libraries, jars for loading in Java, modules and things like that. But they've actually decided to call them notebook libraries, which is a slightly confusing terminology. They're notebooks. And if you add multiple notebooks in, and you have different tables that depend on each other with the live keyword, it will basically pull them all together and still work out the dependencies across those. So you can break your notebooks out into multiple pieces to just make it more obvious as to what's going on. When we run them, there is a debug mode and there is a production mode. So essentially, when you run it in debug mode, it leaves your cluster on for a period of time so that you don't have to keep having a cluster start up every time you want to test something. If you put it in production mode, once the pipeline finishes running, it turns it off. So it saves you money, but if you put it in debug mode in your production and you've got larger clusters, you might find that's quite expensive because they'll just be sat there for potentially an hour or two afterwards. When we run them, we can pick what we want to do. So we can say, I want to do an incremental update, and if you've got anything that's doing incremental updates, it will run it as an incremental update. If you've got anything, and we'll see this later, where it would do a full update, it will still do a full update, even if you select incremental. However, you can say, do a full update on everything, and it will essentially clear down the target tables and just reload everything in. So it makes it quite easy to say, OK, we've changed some little bits and pieces here and there. I want to reload everything in, wipe it out, and it's basically just a different option on the drop-down. And you can choose that per table. So you can say, actually, within my list of tables that I want to run, and within my DAG, these are the things that I want to do, and I want to do an incremental on those, or I want to do a full on those. And you can select the tables very granularly as to what you run. OK, so we'll get into the demos now. Let's start with the first notebook. So for the notebook, essentially, I have a folder within my data lake, and I have the AdventureWorks data in there as CSV files. So essentially, how does this work? Well, let's start with the first query here. Can everyone see this OK? Yeah. So when we look at this particular one here, essentially, we're creating a streaming live table. The reason that we're doing a streaming live table in this situation is because we're using from cloud files. So normally, we might say we want to select it from a table, or we want to select it from a specific file. Cloud files is the piece of magic that makes autoloader work. So essentially, when you say cloud files, you give it a path to your lake, you tell it what the file type is, and then within that map, we tell it what the delimitation is for this one. So this is coming from a CSV file. And in this case, we've just added the input file name to the table so that we can see where it came from. You can add table properties in like you could for a normal table. So essentially, you can add whatever you would normally add, give it descriptions, give it a name, things like that. And that's your basic setup for how you create the table. The next one's very similar, but in this case, you'll notice that there's a slight difference between the paths that we've used. So the last time I did this demo back in October, the paths all had to look like the one at the top. And could anybody tell me what the problem with that path would be? If you look at that, when you go from a dev to a UAT to a production environment, do you want that path to say pointing at your dev environment? No. So this is something that currently isn't in the documentation, and I only got shown this by someone from Databricks the other day. Essentially, if you want to make things dynamic within your SQL notebook, you need to use this $ and then curly braces, and you can refer to a variable that you will pass in when you create the pipeline that is using this notebook. And that allows you to make your storage accounts dynamic, and it lets you then actually build something that could be more productionizable. So the next one here, slight difference this time. We've got the keyword create incremental live table. That's the same as the streaming one. It basically, when they first released this, they called it incremental tables. They've changed the name to streaming tables. The syntax works both ways. I believe incremental table is supposed to be deprecated, so it might stop working, but you might see examples around where they're used interchangeably. It's a little bit awkward to get consistent documentation at the moment. And yeah, in this case, we have a streaming live view. And you can see again, we've got a live view that is selecting from a cloud file source. So what does that actually mean? We have a view that's sat on top of a stream. It basically means each time we access that view, it will only pull back the things since the last time we actually accessed it. So we can actually create a view that's like a slice of what is new and use that to load a table, and then the next time it runs, it will still, from that view, pick up only the new things. The other thing that we can do here as well that's important is we can also create a live table that is pulling data directly from a normal table within your Hive metastore. So you don't have to pull from Autoloader or another streaming service like Kafka. You can pull directly from existing tables. And you can also pull directly from a path on your lake. So in this case, we're using from Parquet. And this syntax is slightly obscure on the SQL side. You can do from Parquet dot, and then you'll see that we've got a path within the backticks, and you need to make sure those are backticks. Normal quotes don't work there, and it just has a paddy that it doesn't like the path that you've given it. It says it's not correct. It took me a long time to work out that they'd use backticks and not normal quotes. Okay, so that's looking and loading our bronze layer. So how do we take that through and actually make sure that we have the dependencies there? Well, in this case, we've declared a new streaming live table. And this one's a silver layer, and we're basically saying, pull the data from live.bronze sales order header. That live dot means that we're taking the data from another table that exists within our Delta Live tables pipeline. So it will look within the pipeline, and it will work out that there's a dependency there, and it will make sure that it runs the thing that we're getting the data from first, and then it will build a new table on top of that with whatever our query defines here. The other thing that we want to do once we get to the silver or enriched layer is we might want to start adding in some constraints to say, well, I've got certain data quality that I want to meet. And we do that using the constraint keyword. So we say, in this case, constraint, give it a name, and then we tell it what we want to actually expect. And when we do that, we've got three options for how we handle expectations. We can say, this is what we expect it to be, and don't do anything, just let us know how many didn't actually match that expectation. We can say, if it doesn't match and it violates the expectation, drop the row, which we've done here. Or you can say, on violation, just fail the whole table, and that will basically stop it from running, and then anything that depends on that further down won't run as well. Okay, and then the next one, very similar. This time we're not making a streaming table, we're making a normal table. So that means that essentially the streaming table, because we're pulling it from a stream and loading it into a stream, it's going to be an incremental load. We're going to take from that bronze sales order header the new things each time and append them onto the silver sales order header. With the next one below, because it's just a live table, not a live streaming table, when we pull the data from live bronze product category, we will basically bin the entire silver product category table and load it fresh every single time. If you're doing anything where your IDs might change, that's something that you want to be aware of as you load things in, because you'll want your referential integrity so that you can join your data back together once you've got it in a data model. Okay, so once we get to the silver layer, or most usually the gold layer, we're going to want to start joining tables together. So in this case, we're looking at something where we're creating a streaming table, an incremental table. We want to add data to it. We've got some expectations. We're telling it where we want it to go. And then we've got a more complicated select query. And you can see again, we've got this from stream. So the stream is saying, read my stream, get me the most recent things that I haven't processed, and run those. But if we want to join things together that are coming from a stream, this is where we get into the limitations of Spark structured streaming. You can't do left joins between two streams without telling it some more information about the time periods that you want to look at. And that's a limitation of Spark structured streaming. It's really difficult to say, from this stream, I want to join these things to that thing, because if one has got behind, how do we manage that? So you're kind of limited for simpler queries to inner joins, or you have to have an understanding of the timings on your streaming, and that starts to get a bit more complicated quite quickly. But obviously, that's not particularly great if we're just trying to do lookups and things like that, where there's a possibility that the thing we're looking up doesn't exist. So that's something to be aware of as you start to play with these. So CDC merge upsert. This is kind of the piece that was available on the Pro layer. And essentially, it's very similar to what we've done before, except in this case, what we actually have to do, so the first one, we're just putting stuff into a streaming live table, and we're saying, put it in there, keep updating it every time. So that's like your SCD 0, you just bolt stuff onto the bottom, and it's going to be a new row each time. But if we want to do an SCD 1, instead of actually creating the table and defining what is going to be pushed into it, we need to create the table first, and then we need to use a second statement, and we need to use the apply changes into, and then tell it the table. We use the keys item there to tell it what the keys to match on are, so that it knows if rows are the same. We use sequence by, and that will allow us so that if we've got data coming in, and say I haven't loaded my data for 3 or 4 days, but I've had files coming in each day, if something is updated and I need to load that particular row, but I've got 3 versions of it, how do I order which one should be the one that I load in? So in this case, you could use something like modified date. You can also tell it which columns you want to load, but you don't need to list all of them. In this case, if we've got a few that we might want to exclude, like for customers, we wouldn't want to load passwords and things into our analytics system, you can just say all the columns except for, and list the ones that you want to exclude. And that's quite useful if you're looking at anything that works with Delta schema evolution. So if you've told it, yes, this table can evolve and add columns onto at the end if it needs to, then obviously doing all the columns except for, you can exclude certain things you don't want and have your new columns flow through. And then at the end, we say stored as SCD type 1. It's as simple as that. And that will actually make sure that it does an SCD type 1 transform on that table. And it will update for us every time. So what if we want to do an SCD2? It's exactly the same. We just tell it to do an SCD2. So none of the complex merge queries that you might normally have written to do SCD processing are used here. It's just simply go and put SCD2 on the end of your apply changes. So as I said before, we can't run this. If I click the run all button up here, it will basically say, this is a DLT notebook. That can't be run. So instead, what we have to create ourselves a pipeline. So where do our pipelines live? They live in the Workflows tab. And within there, you'll see a Delta Live Tables tab on there. And I've created these in advance, but we can have a look at the settings because it's exactly the same. So when you click New on the previous screen, which would be up here, you will get to a screen that looks like this. So we give it a name. We tell it the product edition. So we talked about that before. In this case, I'm using cluster policies to enforce putting my nodes into a pool. So this is something that I came across when I started to play with this. By default, the clusters that it uses use F4 CPU nodes. I had a quota of 10 for that, and I had a very obscure error message where it kept telling me it couldn't start the cluster. And it basically turned out that the default limit is 10 CPU cores for a given region. And when it starts up, I think for the F4s, they're 8 cores each, and it needed a minimum of 16 there. So to get around that, I'm using a pool that is set to use different types of CPU. And I'm using a cluster policy to say, these are the types you need to use. However, it's not quite as simple as that, and we'll get to that in a second. So you've got your source code. So basically, this is where I said notebook libraries. It's a slightly awkward terminology, but you can add a bunch of notebooks, and it will combine them all together and work out the dependencies between things. Then you need to tell it a storage location. So essentially, this is where it's going to go and store all of those log files that track the state behind the scenes. Once you set this, you cannot change it. So you would have to go and remove your pipeline and delete it, and then recreate it if you want to change where those things are pointed at. You also have a target schema. This is basically the database or schema that it's going to store it into in the Hive metastore. At the moment, this is limited to a single schema. So if you're using DLT, you can only write to one at a time. There's also a cluster mode. So there's a few different scaling modes here. The enhanced auto-scaling is a DLT-only thing. The idea is that it tries to turn on more compute, and because it has an idea of which things are going to run in which order and how big they are, it can be slightly more aggressive at turning things off and turning things back on as required, and it can try to preempt that a little bit for you, which should hopefully save some money. You have an option for photon acceleration, and then under the advanced, we mentioned before that we use that syntax of $curly braces to inject our paths into there. This is where you define them. So you put them under configuration, and essentially what's happening here is this is setting Spark config behind the scenes, and when you use that curly braces, it pulls the Spark config that you've set here. So give it a kind of meaningful name, and try to make sure that you're not overlapping other Spark config items. You can also set the channel to be preview, and you can set some tags on the clusters so that you can actually see like how much certain things are costing you. So you could tag them for your different workflows, and then in Azure, you can go and look at the pricing on those things. So we also talked about the fact that I run everything on a pool because it makes it slightly easier for me. Something that's important here is when you look at the JSON definition, you'll see that there's a clusters section. That clusters section, even when I select my pool, will not add the instance pool ID or the driver instance pool ID, even if the policy has them set on them. You need to make them exactly the same as what they would have been within the policy for it to pick it up correctly, which is a slightly annoying little thing. And yeah, if you try to change the storage path from here, even though it looks like you can change it, it will tell you you can't. So I ran this a little bit earlier. We'll zoom this in a little bit. So essentially, I've run this. And how do you do that? You've got the start option at the top. And you could do a full refresh all, which, like I said, will take any thing that's an incremental table, and it will just wipe it out and make it run again. So you can see on these ones, it's got a label that tells us what it is. So in this case, we have a streaming table. We can see that it's loaded 853 rows. If we hit start on this one, you get this little thing, and it will create the update. And it basically looks at our DLT notebook and works out all of the things that are in there. And it takes a few seconds, and then we see a process view, and we can see that this is kicked off and things are running through. And as we zoom in, we can see under these ones, basically where it says we've got this little green and gray item, this tells us how many records we've written and how many records that we've dropped. So we can see that in this case, we've not actually done anything because we're using a stream and we'd already loaded all the data that was available. One of the things that I didn't point out is on autoloader, it's possible to add a filter. So you could say, I don't want to load these files, and you might think that's really useful in dev because you can then go back and change it and load a few more and test that around. One of the things I've noticed with it is that if you put a filter there and it sees a file, it knows it's there. So if you then change your filter and run it again, it goes, no, I've seen that file and you've told me that you wanted to ignore it. And then if you go and rename it or something like that, it will just completely ignore it. So you need to keep moving files around within your lake if you're in dev mode, you want to test the incremental piece. If you click on one of these, you get some information down the side. So this will tell you where the code is actually coming from and link you to the notebook. It will tell you where it's going to go to, the status, how long it took, and it will tell you the schema. If we pick one that has some data quality metrics on it, we should, yeah, here we go. So in this case, where we've got expectations that we've set, we can actually see how a percentage of how many have passed and failed, and the records we can set to show failures only, and we can see all of that information about what the expectations look like. Okay, so that's the first one. Just to have a quick look at the actual tables that have come through. This is the SCD table. I'll just fire off a couple of these. And then in the background, while we look at the next one, so in here I've got an extra customer file. And I'm just going to move that one. Right, so that's moved that into the customer folder, so if I run it again, it would get picked up. So I will start that. And if we look at the check one, we can see that for the customers, we've just got these items in there at the moment. And once that's run in the background, we'll go and have another look at that. Right, so that's the SQL side of it. What about if you want to do stuff in Python? Essentially, in Python, it's very, very similar, but just with a Python-style syntax on it. So the most important thing here is the import DLT at the top. However, again, if you try that in a normal notebook, the DLT module just does not exist, and it won't work. So essentially, we can, to make stuff dynamic and make sure that we can deploy to dev and then UAT and then prod and get our different paths, we do what we would normally do. We pull stuff in from variables, or we can pull it in from secret scopes, or we can pass it in as parameters in the same way that we did for the SQL ones. If we pass it in as parameters, we'll see it a bit further down. You need to get it from the Spark config. So in this case, we're just setting up some paths to make everything work. And then essentially, how do we declare a DLT table? Well, essentially, we use @dlt.table. So the @ syntax in Python is a decorator syntax. And essentially, it's a function that we call, and we can pass in some information. So in this case, we're passing in the path of where we want it to go. You have then a function underneath it. So we've called it bronze product in this case. And bronze product, the name of the function is what the table will be called. And within there, we create a data frame, and we basically just load our data, and we return the data frame from that function. And then DLT will handle all of the actual write piece for that. So we've got a couple of different examples there. So in this one here, Again, we're setting up another DLT table. We've got some expectations. So we use DLT expect, DLT.expect or drop. And then essentially, we're passing in a name, and we're passing in just a SQL string that will go and look at our data frame, row by row basis. So you can't look across rows with this very easily. And it will say, are the things that we're expecting going to work? And we've got a couple of different data frames that we're pulling in by reading streams. And then we're using those and we're joining them together and we're returning the data frame again. Yeah, and that little note on there, when we looked at referring to something within the DLT pipeline before, within the SQL side, we used the live prefix. You don't need to use that within Spark. So essentially, you're saying DLT read stream, and that's how it knows that you're reading a stream that's part of the DLT pipeline that's running. So yeah, a few more queries there. All of this code will be online, so you'll be able to have a look at that. If we tried to use this notebook, we'll actually it won't fail on this error, but essentially you cannot mix your different types of language within a single notebook like we can in a standard notebook. So essentially, we have to have a notebook that is either Python or a notebook that is SQL. However, when we create the actual pipeline and tell it which notebooks to use, you can mix and match SQL ones and Python ones. So it's just something to be aware of. You can't have one giant notebook and put some SQL, some Python within there. And then example 2. So initially, we were saying the name of the function determined what the name of our table was. In this case, essentially, we're starting to look at how can we make this slightly more dynamic. So it's all well and good being able to put this together, but if I've got a source where I've got 200 tables and I want to bring it all in, I probably don't want to type 200 Python functions out or 200 SQL functions out. So this is where we can start to have a look at how we can parameterize things. And then on the next demo, we'll basically see, we'll skim through it quite quickly, but we'll see how we can make that fully dynamic. So at this point, we've got our @DLT table, and then we've given the name option parameter in there, and we told it the name is bronze table. And now, when I give my function a name, I can just call it ingest data, but when that runs, it will call the table bronze table. In this situation, not a perfect table name, I know. And we can pass in the path dynamically, and we can change even the comment dynamically. So, yeah, and by the way, here was the first demo that we run. So we run it again, and there should be, I think it was customer that we were looking at bringing through. It doesn't seem to have picked that one up, so I'll have a little look at that in a bit. So demo 2, I ran this one earlier, so we run the whole thing again. But essentially, when that has run, we'll see that if we look at the warnings on here, we'll see that basically it's telling us it couldn't run that SQL cell because it was a mixed language notebook. And essentially, the Python gives us the same output that we get with our SQL. We've just done a slightly different set of tables. So, okay, so if we want to take that and we want to say, well, I want to drive this off of some metadata and use that to loop over all of the tables that I have, how can I do that? So I've set up a metadata file here. I've got some YAML. And essentially, I've got a list of tables. And within that, I've said for these tables, if I want a bronze table, it's going to be under the bronze tag. If it's a silver table, it will be under the silver tag. Tell it what type I'm going to use. I can give it the format options and the delimiters. So I've set up a bunch of these, and we've added them in. And I've got expectations within there as well. So just here, for example, these are the expectations that I've put in. So how does that work in practice? So there's a few little things. Again, I encourage you to go and grab this off GitHub because there's a few little useful things. So we said before we couldn't run a DLT notebook. Well, if I run this one, I can run all. We'll start that up and leave it to go. So you can see at the top, I said we couldn't use magic commands. %pip is the only one that we can use on a DLT notebook. It only works on the Python side, and it has to be the very first cell. You cannot dot them throughout your code. And then, essentially, the reason that I could run this notebook and have it work OK is I've added this little function in. This might be quite useful for you, because when you get errors within DLT, what you'll find is that you'll do a bunch of coding in here, and then you want to run it. So you jump across here and you hit run. And then when it goes wrong, and I have some that were going wrong earlier, so let's jump into these. So this shows you the history of this as well. I thought you could click directly in, but if we go into it, here we go. So you can get to the history on the drop down. So if we have a look at one of these that failed, this was because I was messing around for some screenshots. If we look in here, quite often, these are really big, awkward Spark Java errors, and actually finding the thing that you want to know, this is what's causing my error, is a problem. And you take that and you go, OK, I need to go and look for in my notebook, and you jump back, and then you forget what you're looking for, and you jump back and forth and back and forth. It's quite frustrating. So being able to actually run something and have it tell you what it's going to do is quite useful. How do we get around that? Basically, we create a function, and we get it to go and get the Spark context out of the notebook, and we basically say, if there's a specific tag in there, which is the browser language, then we know that we're running it in our browser. And in that case, don't actually try and load DLT. We'll put it behind like a gate, and then we'll just print out all the things that are going to happen. But if we're actually running it in proper mode, and we've gone to the other side and we've clicked go, then it will load DLT in, and it'll actually create all the tables and do all the things. So we can see here, if is not debug mode, import DLT. So within here, there is a bunch of various classes in here that just define our DLT entities. So we're basically taking that YAML file and we're turning it into something that's basically an object model so that we can loop over it. And then we have a few functions that will go and read that YAML file in and turn it into the object model. And then we've created a couple of generic DLT table and view definitions. So within here, we'll see that there's a few slightly funny things. So we've got a function, define create bronze, and inside there, we've got an extra function called define bronze. Okay? Essentially, we've got a function that's going to return our function. Why do we need to do that? It's to do with Python scoping. I can't go and run a loop and just keep doing define bronze, because I'm defining the same function name over and over again. However, I can run a loop that runs a function, and that function can keep defining the same thing over and over again because the scope has changed. The decorator is what's important for DLT. When it sees a function that has the decorator on, and that's created, DLT picks it up. So if we run that loop and we're just calling a function, even if it's not returning anything, it is registering all of our DLT tables. So within here, we've got a function called create bronze. We pass in the things that we need. You can see that we've used @decorator. Well, what we've done is we've gone and looked inside the YAML file, and we've said, is it a view or is it a table? And we've picked the correct decorator in. So a variable in Python can be a function. A decorator is a function. So I'm just storing the correct decorator function in a variable, and then I'm using that, and because it's a decorator already, we can say @ and then put the name of our variable. It's kind of a shorthand syntax to get to the correct decorator, and that allows us to basically use the correct one at runtime. And then we've got create silver, which does a very similar thing. So that create bronze function can actually create both a view and a table, depending on what we want to do. Okay. And then finally, we've got a little bit where we're actually pulling in our YAML config and getting our object model back. So we talked about making these things parameterized, and the fact that when we put our DLT metadata onto kind of like the pipeline piece, it's going to pull it in from a Spark config. So we can see that we're actually using Spark config get, and then we've put in the default option so that we can run this. But this notebook can be used to run this demo 3, and then I can actually push this in exactly the same notebook, and I can just add in these particular DLT metadata, landed route path, and lake route path, change those, and I can actually run it for a completely different set of data. So it is a very dynamic setup. And then essentially what we do is we say, OK, we've got our information about what our metadata looks like. We've turned it into something nice that we can work with. So we just say, for each one of them, get the bronze config from our YAML dictionary. If we've got bronze config, create the bronze piece. If we've got silver config, go and create the silver entity. And we're just going to loop over those things that are in our config file. And that's about it for that notebook. So what does that look like when we actually go and run it? In here, we've got one demo 3 that I ran before we came through. So within here, we can see we've got address, and we wanted a bronze view and then a silver table. And if we have a look at this one, we have address, and we can see that we've got a view. So that view isn't available outside of the DLT pipeline. Like we said, it's like a fancy CTE. And then we've got a table that's loaded off of that. And essentially, we can use that to dynamically drive what we're going to do. You don't need to use the same metadata setup I have, but I just wanted to be able to show that you can do views, tables, and everything from it. I have run exactly the same notebooks. The difference is on this one, we can see that there's a lot more tables. So this is a bunch of data about Lego that's in there. And if we have a look at the settings on this one, the only difference is under advanced at the bottom, where we've added the configuration pieces in. So let's jump back to the slides. So what's it good for? It's really good for loading bronze and silver layers. It's got the auto-loader stuff built in. It's clever in the way that you're able to just point it as stuff and just hit go. You can just go, yeah, you know what, I need to wipe out that table and just reload it. It supports all of that. It's really easy to say, let's create something and run it once per day via a Databricks job, via calling it from the API or whatever. And then we can go, well, actually, the business wants this data more often, so we just run the job more often. It supports our streaming data sources. So if we've got data coming in from things like Kafka, we can load that in really easily. But the other thing that we have is documentation has gaps. So some of the little things that I've shown today, you can't find that in documentation. And it's quite frustrating at times because you're looking and you're thinking, this should work, and you can't quite find the answer. So something to bear in mind. Some quick tips and tricks. I might not go through all of these. When you declare a table in Delta Live Tables, you can only define it once. So you can't have two different pipelines, both running and populating the same table. It will not let you do that. The reason is this to stop you shooting yourself in the foot and writing things in different ways that aren't supported. You can't use stream syntax on a table that you have loaded using apply changes. So if you apply changes to load a table, you cannot then use that as a stream source in the next step and do an incremental load off of it. If you are merging changes in, you have to read the whole table to load the next layer. The string interpolation one that we touched on is really important. That one definitely isn't in the documentation. If you change the definition of a incremental table, so one defined with the streaming keyword, if you change that table definition, the query that loads it, it will wipe out the entire table the next time you run it, and it will reload it because it cannot do a change on that. And autoloader, as we said, won't pick up on stuff if you apply a filter and then change that filter, and so that can be quite frustrating for development. Each pipeline runs on its own job compute. So if anybody wants to see this afterwards, come and grab me. But essentially, when you kick it off, it runs on a compute piece. And if you're running multiples at the same time, they all run on their own. Some of the workflow configs, such as making it run on certain types of cluster, you can only set via the JSON and not via UI. But you can use your policies to kind of push that and enforce it. The other thing that I have been doing on there is you might notice that we didn't have any problems actually hitting stuff in the lake. That's because in my cluster policy, I basically tell it what secret scopes to go and grab all of the information to connect to my lake with it. That's something that you might need to bear in mind depending on how you set that up. So that's it for today. If you could give me some feedback, that would be really, really helpful, because I want to try and make this talk as good as possible. So yeah, if you could scan that code and yeah. And after that, I will try and get the slides and stuff up on GitHub in the next couple of days. So if you go and have a look there, you should be able to see all of the information. Thank you very much.